As Rebecca said, my name is Nathan Harvey, and I'm going to talk to you about a bunch of stuff today. Um, so I am the VP of Community Development at Chef. A little bit more about me. I organize and run a podcast called The Food Fight Show. That's a podcast about DevOps and Chef. So if you commute to work and need something to listen to, a podcast is always good, and I highly recommend The Food Fight Show. I'm also the co-organizer of DevOps DC meetup group. We meet monthly, so if you're here in this class, unless you got on an airplane to get here, it's probably something that you should look into. We meet the second Tuesday of every month, except when it's changed from the second Tuesday, but that's like our regular meeting cadence. So you just missed this week's meetup. It was Tuesday. I also am an occasional farmer who loves eggs. Neither one of those are necessarily true. And you can follow me on Twitter if you like. I'm Nathan Harvey. You have to misspell my name, Nathen. The rule in my house was mom picks the names and dad misspells them. So myself and all of my siblings have misspelled names, which have been a delight to have for the entirety of our life. I'm sure I speak for my siblings when I say that. So here's DevOps DC. This is the awesome meeting that you missed on Tuesday. There was someone from CloudBees who talked about the Jenkins workflow, and someone from a local startup called Fugue who was talking about managing secrets at scale. Two excellent talks. But come back in February and you'll get to go to some awesome talks as well. I'm also the lead organizer on a conference that we run here in DC. This will be the second year we're doing it. It's called DevOps Days DC. This is a 2-day conference that is half talks and half open spaces. It's a really cool format and a lot of fun. It's being held at the U.S. Patent and Trademark Office on June 8th and 9th. You can check out DevOpsDays.org to find information about that DevOps Day, as well as others that are coming up in the area. That's all of the quick commercials that I want to share with you this morning. So now we can talk about continuous delivery and compliance and workflow and things like that. So what I'd like to do this morning is just kind of actually hijack the class, take you out of whatever materials Rebecca has to show you, and show you some of the cool new stuff that Jeff has been working on and how you might be able to utilize that. So I hope that's cool with you. If not, too bad, I'm going to do it anyhow. So I'm glad that you're here. I'm glad that you're here. That's awesome. As you're learning and getting better skills with Chef, really you're probably learning this stuff not so that you can become a better coder with Chef, but because you want to provide more value to the business that you're running. You want to provide more value to your customers. Some of the ways that you do that are through DevOps workflow and culture. So if we talk about this term DevOps, it's not just tools, and it's not just people, it's not just workflow. It's really all of these things sort of working together to drive success in your business, to drive collaboration, to drive happy customers. That's really what DevOps is all about, driving high velocity also. We do DevOps so that we can get to this place where we have continuous delivery. We're deploying changes all the time throughout our infrastructure with our applications. Again, it's in service of our customer. What is our business about? I'm not going to read you slides, so I hope you read them quickly because I'm going to keep moving. But of course, as we move fast, we can't give up security and compliance. We probably all live under some sort of or some level of compliance regime. There are controls that we have to follow within our infrastructure, within our applications, whether those be PCI, HIPAA, or just I want to be secure, I want to be compliant. And so we can't forget about those things. So let's talk about continuous delivery and how do you implement continuous delivery with Chef? What are some of the considerations that you have to make when you want to go and implement continuous delivery? But maybe we'll take a step back and talk about why. Why do you want to get to continuous delivery? One of the biggest benefits of continuous delivery is it allows you to manage risk. Risk that you put into your production environment, risk that you put in front of your customers. The idea here is that we're going to deploy things in very small batches where we can run quick experiments and get feedback from our customers. We're going to increase our near-term volatility, but we're going to gain decreased long-term risk. So by pushing out small changes very frequently, yes, things are going to change a lot, But over time, what we're going to do is decrease our risk. Our systems are going to be more stable. We're going to get things in front of our customers and learn from them faster. If you think about the way your phone works, it gets updated all the time, right? Applications are being pushed out to you. You might not even notice that you're getting new applications, new updates to your applications on your phone. Our customers want the same thing from all of the applications that we're building. Whether those customers are end consumers, whether they're constituents, whether they're just other people that work in the same company as you, we all expect this speed. Now, if you want to get to continuous delivery and start delivering things in small batches, the very first thing you need to do is start using version control. So if you're not using version control, what you should do is not be in this class at all. You should have spent the last day, and you should spend today learning Git, because version control systems are where it's at. You have to start there. That's like step 0. I'm going to make the assumption, I hope it's a safe assumption, that everyone in this room is using a proper version control system. Everyone doing that? Yeah? You should lie to me if you're not, and just nod your head. Yes, I'm totally using a proper version control system. So another thing, another consideration that we need to think about when we talk about continuous delivery is a step that also comes before we get to this idea of continuous delivery is continuous integration. Now, I used to be really smart and know what continuous integration meant, but I was completely wrong. So let me tell you how I used to think about continuous integration. I used to think that continuous integration meant that as I start a new feature branch, what I should do is start running all of my tests against that feature branch and make sure that every time I do a check-in against that feature branch, that my tests are executed against that feature branch. And that sounds pretty good, like I'm always verifying that my feature branch continues to work. But that's not really continuous integration at all. Continuous integration doesn't mean running your tests on your long-lived branches. It means never having long-lived branches. You have short branches that you're continually merging back into your master branch. And your tests, of course, are continually being run. And then you also have to have this belief or this discipline as a team to fix the build when it goes red. So you're running your tests all the time. When your build goes red, you should stop what you're working on and fix that build. This is the only way that you can get to safety. You have to be continuously integrating, and you have to fix the build when it goes red. When we talk about continuous delivery, if what you're thinking about is continuous delivery without continuous integration, without the discipline to fix the build when it goes red, without actually running automated tests, you're running continuous delivery without a safety net. That's ridiculous. Don't ever do that. You want that safety net. You want those tests, and you have to have the discipline to fix things when they break. With a continuous delivery system, you want to practice the 4I rule. The 4I rule is simple. It states this: no code gets into the hands of our customers or gets put into our production environment without at least 4 eyes looking at it. Now, a couple of us in this room are awesome. The code that we write is production ready the minute we write it. Yeah. Because I wear glasses, so I practice the 4I rule every single day. Of course, wearing glasses does not excuse you from practicing the 4I rule. You must have 6 eyes look at that minimally. So get someone else on your team to look at the code to make sure that what you've written is correct. It follows the standards within your organization. He just put on his glasses. Now your code is ready. It's good to go. Well done. Make sure that it's good. Make sure that you've followed your standards. Make sure that it's doing the right thing, and make sure that it's not doing something that is potentially harmful. You also need to write tests. Now, when it comes to writing tests, I've seen this happen many, many times. People will get into a room and they will argue about what makes a good unit test, or what makes a good integration test, or what makes a good functional test. Heck, they'll argue about what's the difference between an integration test and a functional test. They'll sit around for hours discussing this. I will tell you what makes a good unit test. A good unit test is a unit test that you execute, that you run against your code. That's the thing that makes a test good. You run it all the time. The thing about tests is this: if you're just getting started with tests, the tests that you write today are going to be shitty tests. The tests that you write in 6 months are going to be better. Just like when you first started writing code, the code that you wrote wasn't great. You learned more about the craft of writing code, doing the right things. The tests are exactly the same. You're going to get better and better at unit testing. You'll get better at integration testing over time. The important thing is that you're writing these tests and that you're executing these tests. So when it comes to the tests, unit tests will test a single function. Integration tests will test multiple classes or units. Functional tests are user-oriented, high level. They'll do the full stack of your application. And then smoke tests are something that's done just to quickly verify that the system is working. It's not a comprehensive test. It must be fast, and it must make sure that the system is working. A smoke test on a website might be something as simple as, if I go to the homepage, do I get a 200 HTTP response? I might have thrown in an extra T there because I had 2 cups of coffee this morning. But I get a good status code coming back. Another thing that's going to drive towards a good continuous delivery system is if you have one path for change. The way that change moves through your systems must be fixed. And it should be designed to reinforce your principles and these ideas around continuous delivery, things like the 4i rule, things like continuous integration. And it must be flexible at some level, specifically at the level of execution. Now, when we think about moving change through your organization or moving change through your infrastructure, how many of you have emergency change procedures within your, yeah. So when we go out and do studies of large companies that have different change boards and different change procedures for how things get into production, when you sort of drill in on the emergency change procedures, typically an emergency change procedure means you're excused from running the tests. You can just push that change into production, right? You're nodding your head like, yep, that's exactly what ours means. Well, think about that for a minute. That's fucking ridiculous. Sorry for the language, but really, that's ridiculous. Why wouldn't you run your tests? It doesn't matter if it's an emergency change or a standard change. Every change should follow the same path, should move through your organization the same way. The other thing that's important to remember is that all of your code should go through the same workflow. So whether it's infrastructure as code or applications as code, the key there is it's code. You're not having different pipelines or a different process for how you move these various points of code or pieces of code through your organization. They all should go through the exact same workflow. So those are some of the principles or ideas around how do you build a solid continuous delivery system. And so now what I want to do is kind of drill into the Chef workflow and how the various components of Chef allow you to build a workflow that works for DevOps. So here's our proven approach to DevOps. And what we're going to do, what I'm going to do over the next 20 or 30 minutes or so, is take this workflow and we're going to break it down and we're going to go step by step. We're actually going to move a change through our entire organization. So let me just set up what the change is going to be. And in order to do that, I want to just show you the application that's running in production. So I have this very simple application. You know it's simple because its name is Simple Web, so it's very simple. But here's what it looks like. It's just some static HTML page. It says, hello, Chef Software. I want to show you the code that builds this. So we're going to look actually at a recipe that builds this out. So let me open up the default recipe. Move this over here. See if I can just bump this up a little bit. There we go. And go full screen there. All right, so I'm going to just walk you through this recipe really quickly. It builds out that website. It's pretty simple. Hopefully, this is an intermediate class. You should understand everything that I show you here. So first, it includes a recipe that installs Apache.
Windows folks.
Yes.
Visual Studio.
Not just Visual Studio. Visual Studio Code.
Visual Studio Code.
Visual Studio Code is awesome. So here we are. We're including a recipe called install Apache. You can imagine what that's going to do. It's going to put Apache onto this box. We have a template that's our HTTPD config. How many have managed Apache before in their life? It's cool if you haven't. Most of you have.
We did it yesterday.
Oh, yeah, you did it yesterday. So if you didn't raise your hand, you were lying. It's cool. I like to lie too. So we write out a template for our HTTPD conf. We set a variable for tarball, and then we grab that tarball from S3. So we're just going to go grab a thing called webfiles.tar.gz. We're going to lay down an index.html, so a home page. And then we're also going to finally extract the web files. So we'll do a tar command to extract that web files that we just downloaded. Now, if we look at this index.html.erb, that's over here. There's a line here, line 58, that's highlighted. It says hello, node, site dbaz, company name. And if we go back to the web, we can see that here. Hello, Chef Software Inc. So if I were to, now, you didn't know I was going to ask you questions, but I'm going to. If I wanted to change site dbaz company name, where should I look in my cookbook, do you think? Yeah, in my default attributes. So under attributes, I have a file called default.rb. And here, sure enough, you'll see site dbaz, company name, and it says Chef Software Inc. So let's just change that. I'm going to say hello to Washington, D.C. instead. And then before I go much further, there's one other thing that we wanted to do. So if we come back to our approach to DevOps, one of the things that is relatively new with Chef is this thing called the Chef Compliance Server. What the Chef Compliance Server can do is it can go out and scan nodes in your infrastructure and run compliance tests against those nodes in your infrastructure. So let's actually take our running simple web app and let's scan it for any vulnerabilities that the Chef Compliance Server will pick up, because we may need to remediate something along the way. So if I come back over here, we can look at the compliance server. So this is what it looks like. Within the compliance server, I can set up a number of environments and then point to a bunch of machines. So let's look at this CAD Simple Web. That's my production environment here. I'm just going to click into this, and I want to show you, what do I want to show you? I want to show you how we configure that. Here it is, down at the bottom. So the way that we configure this is we give it a name, we point to its IP address, and then we need some way to log into that box. And you can log in with either SSH or WinRM. So as you can see, we're using SSH. We're logging in as the Ubuntu user on the default port, and we're using a key pair. So I could log in with username and password, or I could log in with a key pair. So the nice thing about compliance is it does not require anything installed on the remote machines that we're scanning. As long as I can SSH into that machine or WinRM into that machine, I can run my compliance scans against that. Now, from the compliance server, you also can manage a bunch of compliance profiles. So I'm going to just jump over here to compliance, and you can see that there are some profiles that come built in with the Chef Compliance, some that we've maybe added. As an example, we've added a profile called the Basic Web Server Security. Obviously, we're running a website, so let's look at that basic web server security. These compliance profiles are written in a language called InSpec, I-N-S-P-E-C. InSpec looks a lot like ServerSpec. In fact, it kind of learned everything from ServerSpec and added some additional stuff on top of ServerSpec to make it even more awesome. So with InSpec, as we create rules, we'll call them rules. So we give the rule a name. So this is rule basic 1. And then just like a resource in a recipe or something, just Ruby code will have a do and an end, and that will wrap or create a block that is our rule. Within our rules, we're going to describe a test just like we would within ServerSpec. So this says describe file etc apache2 httpd conf. Its content should not match options indexes. Also, we can see here that this is saying you should not turn on indexes in your Apache config file. Everyone knows what that means when you turn on indexes. It basically means if you go to a directory path and there is no index.html within that directory path, what Apache will do is show you the contents of that directory. And then you can click into other directories and see the files that are there. And that's not a very secure way to run your system. You want to make sure that that is turned off. So with this rule, I can actually write a test to verify that that's the case, that it does not allow indexes. But then the other thing with InSpec, when I create rules, is I can set a criticality or a level, an impact level. So we're setting the impact level to 1.0, and then both a title and a description for the humans to read when they see that this vulnerability has met. So Apache should not allow directories to be indexed. That's my title. And the Apache server should not allow directory indexes is my description. So let's go ahead and go back to my dashboard. And I'm going to go to the CAD Simple Web. And I want to go ahead and scan this thing. And you'll see that I can select which compliance profiles do I want to execute that scan against. Let's keep things simple and just run our web server check. And if I scan that now, what we're going to see is that there is a critical alert. So this thing is failing. My web server check fails, and I can see the details here. So Apache should not allow directories to be indexed. And then it tells me here, path etc Apache 2 HTTP conf should not match options indexes. So right from this dashboard view, or right from this view of this node, I can see what the problem is. Okay, so this is, at a quick glance, Chef compliance. What questions can I answer for you about this before we go remediate this problem?
Is this is this a service you have to get if you're subscribed to a hosted Chef? I guess would be the right term, or is it something you can stand up on your own?
This is something that you stand up on your own. Chef compliance, we do not offer today a hosted version of Chef compliance. Which is probably good because, remember, the compliance server reaches out, whereas if you have hosted Chef, your Chef client is reaching out to the server, whereas Chef compliance reaches out to the nodes that it's scanning.
So you have to open some scary files.
Yeah, you probably wouldn't want us to do that on your network.
I trust you, but no.
You should trust us. You should totally trust us, but also don't trust us.
But also,
Yeah,
no.
yeah, also no. Right. Yeah, so you can stand up a compliance server on your own.
You should trust us because we won't allow you to do that.
Right.
Don't.
And you had a question.
I think the same question, Nathan.
Okay.
Because different organizations are using different methodology of tenable SSE for
Yes.
a scanning system. So
Yes.
if I build all my nodes or my infrastructure based on Chef,
Mm-hmm.
so I may not use SSE or tenable to run all vulnerability critical media.
Right.
So if it might replace if I use this Chef component.
Yes, you could use this to replace that. Now, one of the really nice things about Chef compliance is that in-spec language is very accessible in terms of how do you write those controls or those rules, and you can manage those just like you would a Chef recipe. So you'll manage those in version control. You can deploy those following a continuous delivery pipeline and so forth. Yeah. Okay. You had a question also.
Oh, I guess that was my question, whether
Okay.
or not you could put it in the pipeline and run it automatically.
Sure. Yep. Absolutely. Absolutely. Okay. So if we come back here to our workflow, we've just run an assessment. We've looked at our infrastructure and we see that there's vulnerability. We also have a change that we want to make to our website. So I already made the change, but let's go and address that vulnerability. And the way that we're going to do that is using Chef Development Kit and do some local development to fix this problem. We'll model, build, and test using our cookbooks, using a test kitchen, and so forth. So let me come over here to this, and I'm going to just bump up the font so that you can actually see what I'm doing. If I click on the right place, let's take this to full screen. Let's change my settings. There we go. Okay, so here I am logged into that cookbook. You can see that I'm on the master branch and I have some change. If I do a git status, we'll see that I've changed the attributes default. Remember, I changed that back in Visual Studio Code. I changed the company name from Chef Software to Washington, D.C. Now I'm making changes. So if I'm actually making changes, what should I do with git before I do much of anything else?
Git add.
Not git add yet. I'm going to do something before I git add this in. What might I do?
Git pull.
I should do a git pull. Yeah, so let me just do a git pull and make sure that that's okay. It's already up to date. So then what else should I do?
You should have made a branch.
I should make a branch. That's a good idea.
This is
So
extreme continuous integration.
yeah, let's go ahead and make a branch. Let's do that. So I'm going to do a git checkout -b, and I'm just going to call this branch the chef demo. Everybody okay with that? Is that a fair
fair name for this branch. Okay. The other thing I want to do here is let me just do a kitchen list, see what do I have going on. And while that runs, let's go ahead and take a look at my test kitchen. Oh, well, it just came back, so that's good. So I have an instance, default EC2 Ubuntu. My driver is EC2. That's pretty cool. So what I've done on this workstation, I'm spinning up a test kitchen over on Amazon's EC2. And the last action was that it was created. Let me just go ahead and run a kitchen converge, and then I want to look at some code. So while this is kitchen converging, let's take a look at our kitchen YAML. You can see here that our driver name is going to be EC2. So this is how we spin up a machine over on EC2. But let's take a look at our suite and see what's in our run list. So there are 2 recipes in our run list. Our default recipe, which is what stands up that website, and then a second recipe, Ubuntu Audit Apache. Let's just take a look at that recipe really quick. So this recipe is using audit mode. And the way that audit mode works with Chef is if you include any recipes with audits within them, they will get executed at the end of your Chef run. Chef will know which recipes have them because it will look for control groups. So here's a control group, validate Apache config with 1 control. And as you might imagine, this is the exact same test that we have on the Chef compliance server. So it expects this file to not contain or not match options indexes. Whoa, sorry. There we go. So let's take a look back here on our test kitchen and see what's happening. So here it's installing Apache. Here now we're starting the audit phase. And we see that the audit phase failed. I don't know if you saw that, but I can scroll back up. And it says so right here. Validate Apache configuration, ensure directory listing is not allowed. Does not allow directory listing, and it failed that 1 control. So I want to fix that control. So let's come over here. Remember, our Apache config was laid down with a template, this site dbaz h.erb. So here's the line that we need to change, directory var www, options indexes, follow symlinks, and multi-views. So I just want to remove that indexes. I'm going to save this change. And then there's one other thing I should do with my cookbook. What other change should I make to my cookbook?
Bump the version number.
I should bump the version number. Great. And where do I do that? The metadata.rb. That's exactly right. So what version number should I set this to?
Anything higher than 29?
Anything higher than 29. All right. Cool. How about 30? Everybody like 30? That meets the criteria, right?
Yeah.
Okay, good. Let's go ahead and save that. Okay, so now I've made those changes. Let's come back here and make sure that if I were to run kitchen converge again, that this actually fixed the problem. So I want to make a change, test it locally, make sure that it works out. So it's going to just grab those files, run a chef converge, start my audit phase. You can see that it changed that file, starting the audit phase, validate the Apache config, ensure the directory listing does not allow it. One example, 0 failures. So we're good. Locally, I've built and tested that change, right? So, so we've now scanned, found a vulnerability, used Chef Development Kit with our cookbooks and Chef Client to model, build, and test the change to my cookbook. And now what I'm ready to do, after I'm done with my changes, is share them with the rest of the group. So I'm going to start the collaborative development. And this is where we'll move into Chef delivery. So now I'm ready to push this change out to production. This is what the shape of a Chef delivery pipeline looks like. These are the steps or the stages that we have to go through. So I've written a change. My next step is to submit that change. Once I've submitted it, we will verify it, approve it, build it. It will go through some acceptance. We will say we're ready to deliver it, and then it will go through union rehearsal and delivered. We're just going to walk through each one of these steps stepwise. So let's start by submitting the change. And so the way we submit the change is we come back over here, and if I do a git status, we'll see that I have 3 files that have been modified: the default.rb, the metadata, and the template for site dbas. Now, I changed the attribute so that we can see when we look at the web browser the change. We can't look at a web page and know our index is allowed or not. We have to rescan with compliance. But I want a visual change that we can watch move through this pipeline as well. So I'm just going to git commit all of these files, and I'm going to say update the company name. So I'm going to say that we're going to update the company name, address the compliance failure, and bump the version.
I guess you addressed the audit failure as well, right?
Yes. Except it doesn't like. Yeah. How about that? I'll do it as a one-line commit. Homepage and audit fix. There, that's so much better. Okay, so now I'm ready to submit this change. So I'm working in a Git repository. So how would you normally submit a change that you have? What might you do? We did a Git pull to make sure we had the latest and greatest. So what might you do now? Yeah, I might push them back up. But now that you know the right answer, I'm going to tell you you're wrong. You should git push it, but we don't git push. What we do instead is we use the delivery CLI. So Chef Delivery comes with an open source delivery CLI or command line interface. And so what I'm going to do is this command, delivery review. What delivery review will do is it will take this branch, this change, and it will submit it up to the Chef Delivery server. And then it's going to open up the delivery web UI for me. So Chef Delivery itself actually becomes your remote repository for your GitHub or for your Git repository. So there's a remote on delivery. And when we do a delivery review, it takes our change, pushes it up to that remote, and then it opens up the delivery web UI for us. You have a question?
What if you use Jenkins? So normal Jenkins, if you have your site, is there?
No Jenkins.
Oh, no Jenkins. Oh, man.
Yeah.
Oh, yes.
Yeah. Okay. So now that we've submitted the change, let's come back here and look at what's going to happen next. I want to show you first, and then we'll I want to talk about it first, and then I'll show it to you happening for real. So we submit the change. Now, delivery is going to run through the verify stage. Each one of these blocks we call stages. Each stage is made up of a series of phases. So we've submitted our change. The verify stage has 3 different phases. It's going to automatically run a lint test, a syntax check, and a unit test against our changes. So this change is a cookbook. We've changed a cookbook. So how do you lint a cookbook? Anyone know how you run a lint test against a cookbook? What tools would you use for that? Rubocop, yeah?
They're on the list for today.
Yeah? Rubocop, and there's another one that you use. Food Critic, exactly. So Food Critic and Rubocop will be executed during the lint test. Syntax checking, it's going to use knife cookbook test to validate that you have good Ruby code, like that you didn't leave off an end or have an extra end. And then for unit testing, do you know what it will use there? Any guesses? For unit testing, how do you unit test? How do you unit test a cookbook? Do you know that? Not kitchen. Kitchen is beyond.
The one that you were talking about.
Unit testing a cookbook.
Chef spec.
Yeah, that's exactly right. So it's going to use chef spec. Now, what if this were a Java application? Anybody here deploy Java applications?
JUnit or something?
Yeah, like JUnit or something like that. Exactly, right? You would not use chef spec to test your Java application. That doesn't make any sense. You wouldn't run Food Critic against a Java application or a Rails application or a .NET application. So we have to be able to customize what happens during these phases, and we'll look at how we do that. But let's see these things running here. So if I come back to my web UI, we can see here's the homepage and audit fix that's running through. It's in the verify stage. Verify has passed unit, lint, and syntax. Now I can drill in to any one of them. So if I, as an example, open up the unit test, we can see that it's running chef spec and it's passing. So that's good to go. We can close that out. We can also look at the output from our lint test. And you can see here, you probably can't see, you can trust me though, it says execute Food Critic, so it's checking for correctness. It's also executing Rubocop along the way. And so all of our tests here are passing. So we're now ready to move into the approval stage. And the approval stage is where our 4i rule comes into play. So what I can do with this change is I can review it. If you see I'm in the upper right-hand corner there, I'm going to click Review. And now I can see there were 3 files that were changed. The attributes file was changed. We changed from Chef Software to Washington, D.C. Our next file that we look at is the metadata file. We changed from 1.29 to 1.30. And then our third change is our HTTP conf. So I can see that options indexes, the indexes bit was removed from that line. Now, in addition to seeing these changes, I can also comment on them. As an example, I could come in here and leave a comment on version 0.1.3.0 and say, is that really proper? Is that really proper semantic versioning? Like, didn't you just break something by turning off indexes? Should this maybe be 0.2.0 instead of 0.1.30? Like, we could argue about that all day. We're not going to argue about that at all. I'm just going to add that comment, and then we're going to move on. So if we come back to the review, I've now reviewed this change. Oh, and while we're here, actually, let me just jump to the dashboard really quick. Because one of the other great things about delivery is it allows you to view and sort of visualize change moving through your organization. We can see that we have one active project. It's the site DBAS. It's already been through the verify phase. It's currently sitting in the approval phase. You had a question?
Yeah, are we reviewing on the branch?
Yes,
okay.
we are looking at the branch. That's exactly right. Okay, so I'm going to come back into review. Yeah, did you have a follow-up on that?
I don't know. I guess I was just looking up there. It says
chef demo going to chef site DBAS.
Yes.
That's
okay,
the chef
okay,
demo
I see.
branch.
This is the branch name that I
Okay.
gave it. Yep, and it's going to merge into the master branch.
Okay.
All right. So are we ready? Do we feel like this change is good? Yeah.
If I had a login, I would have.
All right. So Rob. I'm just going to leave a little comment there that says, Rob said ship it. And you can see that it's cool because we can get little emoticons in our comments, in our commentary. So Rob gave me the approval to ship it. I'm going to click the approve button. So when I click approve, it's going to throw up a little modal, confirmation box for me. And it says, are you sure you want to approve this change? After approval, this change will be merged to master. Remember, continuous delivery means that we practice continuous integration. The first thing we want to do, like the thing that we drive towards first, is getting this change merged back into master. So I'm going to go ahead and confirm that. And then while that's, it moves on to the next phase, or the next stage, which is the build stage. But let's just take a look at exactly what's happened here. If I git checkout master, and then do a git pull, we can see that it's going to actually pull down those changes. So that change has fully been merged into master. I can do a git log, and we can see here's the change that I made, and then here's the merge commit, and we can see that who signed off on it, who reviewed this change, and so forth. Now, typically, you're going to have someone different that committed it than who reviewed and signed off on it, but that's cool. So now that we're in verify approval, we're now in the build phase. Let's look at the phases that happen during build. So in the approval phase, the thing that we do here in this approval stage, this is a human gate. And the question that we need to ask or answer is, does this code change look good? So it's typically going to be another engineer that looks at that code to say, yeah, you wrote good code, argue with you about semantic versioning, things like that. Say, hey, you use double quotes, our standard is single quotes, whatever it is that falls outside of these things, you're going to get someone else on your team to sign off on that change. And then we move into the build stage. And the first phases that we run in the build stage are lint, syntax, and unit. But we just ran lint, syntax, and unit over here in verify. Why are we running them again? What's that? Right. Over here we ran them on the branch. Now we're running those same tests again on the merged commit. So between the time that we ran those tests on our verify and the time that it got merged in after our approval, something else could have come along under master and changed. So we want to make sure that we're still passing our lint, syntax, and unit. Now when that's done, we'll run security tests, we'll run our quality tests, and then we have an artifact now that we've built, and we'll take that artifact and publish it. Now the artifact that we're talking about here is a cookbook. So what does it mean to publish a cookbook, do you think? Upload it where? To the chef server, exactly. So our publish phase here is going to take the cookbook and put it onto the chef server. But Rob wants to argue with that. Go ahead, argue with that.
I submit that you could publish it to a supermarket and make it available because cookbooks are libraries.
That's right. You could very well publish it to a supermarket as well. But the cool thing is you control that within the definition of what this phase is. Yeah. So in our demo, what we're going to do is publish it to a chef server. So you're right. He's wrong.
I'm wrong.
Okay, so let's check in on that and see how it's going before we move on to the acceptance phase. Okay, so build has completed and acceptance is currently running. Actually, acceptance completed also. So in the build, we did our unit, lint, syntax, quality and security were skipped, and then we published it. And when we published it, we took that thing and we put it onto a chef server. It is now in acceptance, or then it moved on to acceptance. So in acceptance, we do a couple of things. We provision a new acceptance environment. So we spin up infrastructure on which to deploy this change. If I look up here in my tabs, there's a tab here called Acceptance CAD. This was a running node already that had the previous version of that cookbook run on it. Now that acceptance has run, if I refresh this page, Chef Software should go away, and we should see Washington, D.C. And sure enough, we do. So let's come back to our change and see what happened during acceptance. We provisioned, we deployed the change, then we run our smoke test and our functional test against that environment. So now we're at the stage where we're ready to deliver. So again, going back to our little chart here, our workflow, acceptance, we provision infrastructure, we deploy that artifact, we run our smoke test and our functional test. We're now at our second of 2 human gates in this process. And now we ask the question, do we want to ship this? Is this ready to go for our customers? So whereas during the approval phase, you might have asked another engineer, during the deliver stage, you're probably going to ask your product owner, hey, is this thing ready to ship? Is it good to go out to our customers? If so, click that deliver button. Now, the other thing that I want to point out is we made, in addition to the UI change, we also made a change to the security of that machine, right? We changed that indexes thing. So if I come back to Chef Compliance, if I scan the CAD acceptance node, let's make sure that that's actually fixed our problem with the admin web server check. Now, admittedly, we didn't do this in advance, so even if it works, like, that's smoke and mirrors potentially, but sure enough, it is compliant. So before we move on, let's look at the the union node. Let's go ahead and scan that, run the same test against our admin web server check, and we're going to see that this is going to fail. So again, we have one critical alert. It's that same critical alert we saw in production. So let's say we're ready to deliver this change. Once we click that deliver button, this change is going to move through union, rehearsal, and delivered. I'm going to click the button and then I'll talk about what each three of those stages are. So I'm going to go ahead and click that. The following change will be shipped to union. Are you ready? Are you ready? All right, I'm going to confirm it. All right, there we go. So it's off to union, and I can see here that union is going through its provision phase. Let's just take a look at these different things and talk about them. So in union, we're going to run the same three tests, or the same three phases that we ran when we were in acceptance. We're going to provision, deploy, run our smoke tests, and our functional tests. If all of these pass, we're then going to take this change and move it along to the rehearsal environment, and finally on to the delivered environment. Now you can think about delivered as this is where our customers are going to interact with that thing. You may call that production today. We're going to call it delivered moving forward. Now, the beauty of union, rehearsal, and delivered can be seen here on this slide. What you have with union, rehearsal, and delivered, each one of your applications or each one of your components that make up an application have their own individual acceptance pipelines, but you bring them all together in the union, rehearsal, and delivered environment as your delivery pipeline. So as an example here, we have applications and we have cookbooks. So when you think about it, if you're running microservices, right, 8 different microservices make up one thing that a customer interacts with. If I make a change to one of those microservices, I want to test that microservice with the 7 other components that make up the application that the customer interacts with. So here, again, we go back to some of our principles of continuous delivery. Your infrastructure code and your application code follow the same process. So if I have an application and a cookbook that supports that application, they both go through this exact same workflow. So the change that we've made to this cookbook will come into the union environment with the latest version of all of the other components. We will then run our smoke and our functional tests within the union environment. Let's take a look at how that change is coming along. So it has completed union. Union did its provision, deploy, smoke, and functional tests. Now we have the smoke test currently disabled, so we're just skipping those tests. We're now into the rehearsal, where it's doing its provision, deploy. And what we can do with we can check union in the web browser. So we can refresh this page, and sure enough, our change has been delivered there. And we can also this was our union environment here. Whoops, let me go back to my dashboard. Grab the union node. I can scan that. Just the web server check. We'll see that this should pass as well. Sure enough, this server is now compliant with that particular test. Let's check in on how we're doing here. Rehearsal is currently running its functional test, so it has been deployed. So even while the functional tests are running, I can come over here and refresh the page and see that it's updated to Washington, D.C. And again, I can scan the rehearsal node. Well, rehearsal, scan, just the web server check. And sure enough, that's going to pass. And then finally, it will move into the delivered environment and deploy that change. So this is what the sort of the chef workflow looks like. The idea is that you will start off by scanning your running infrastructure. If you identify any vulnerabilities, you will remediate those using your cookbooks, using local development. Also, not only just for vulnerabilities, but if you want to make functional changes, like we changed the welcome message, we'll model that locally with the Chef Development Kit in our cookbooks. We'll then collaborate with the rest of our team by using Chef Delivery. And again, delivery can be used for cookbooks, but it can also be used for your Java apps, for your Rails apps, for your .NET apps, whatever. We then take those changes, get them onto our Chef server, if that's appropriate, depending on, if it's a cookbook, if it's a Rails app, it probably doesn't go onto your Chef server. And then we get it deployed into our delivered environment out to our target workloads.